Okay, for the math students, I'm here with some of the solutions from the questions of exercise 15A. Okay, the first question says, in each of the following, can you show this question? Following, use the relation V is equal to R omega to determine the unknown value. So now, like coming on to this, in the first part, we're given the V, we're given the R, we have to find omega. So we know that V is equal to R omega. So by just substituting your V and then your R, you can find this omega. Similarly, in the next question, you have again this V is given as 6. You have to find R and you're given the omega. You can find this R, okay? And similarly, in the third question, you have been given R and omega. So your V is going to be 5 into 0.8. Okay? So remember their units. Your velocity is in meters per second, R is in meters, okay, and omega is radians per second. Now we go to the second question now. I believe you have the books, okay, so I'm not going to show you the question, so you can look at the question. It says a particle of mass 0.2 kg is attached to a light inextensible string of length 1.5 meter. So let's say this is the string 1.5 meters, and here is that particle attached to it. Its mass is given as the mass is given as 0.2 kg. This is 0.2 kg, and the radius, the length of the string, the string's radius is, it says attached string of length is, so this is basically for this, the radius would be 1.5 meters, okay. And then it says the particle is moving in horizontal circles. Yes, we are dealing with the horizontal circles. Find the tension in the string if the speed of the particle is 5 meters per second. Now remember, when we say speed, you must be clear if it's a speed or the angular speed. So the speed is 5 meters per second. So we have to find the tension in this string over here. So the tension would be in this direction, okay, keeping the particle in this circular path, okay. So we have that F is equal to, there are basically the formulas, they're here, okay. So your F is either, if you use that MA, and your A is either R omega square, or this is your V square over R. So in this situation, we shall be using this formula. So this F is basically the tension here, and that is mass is 0.2 times the acceleration is going to be V square over R, that is 5 square over 1.5. So that is how you will be able to find the tension in this string, okay. Now I'm going to take you to the let's try the fourth question now, okay. You can try the third question yourself. A particle is describing horizontal circles on a smooth horizontal table, okay. So horizontal circles like this. Now this is smooth, okay. Remember, if it's smooth or rough, you have to take a note of it. A particle is describing horizontal circles on smooth horizontal table. The particle is fixed to its circular path by an inelastic string of length 1.5 meters. So this length is 1.5 meter here, okay. Given that the tension of the string is 45 newtons, this is 45 newtons, the tension towards the center, okay, and the mass of the particle is 5 kg. So the mass is 5 kg. So we have to find the angular speed, where is that? Find the angular speed of the particle. So we are going to find the angular speed. We have F equal to, this is going to be mr omega square. So this F is going to be 45 over here. The mass is 5. The radius is 1.5. And this is going to be times omega square. So this omega is going to be, 9 divided by 1.5. Yeah, so this is going to be under root 6, okay, radians per second. When it says state also how many seconds a particle takes to describe one complete circle. So you see, this is this much radians in 1 second. So when it takes the whole, like, for the whole revolution, this is going to be 2 pi over omega. That is the time taken. Okay, so this is going to be 2 pi divided by under root 6. So you will get the time taken for one complete revolution. Okay, now I'll be taking you to the 10th question, and then you can try all the rest yourself. Okay, let me find if I have a blank page over here. Yes, I have. Okay, the 10th question. Oh, this seems to be a very dangerous, khatarnak type of a question. Let's try the 10th question. Okay, a particle P is placed on a large rough horizontal disk. Now this is rough. Okay, I'm just going to note it down. This is rough. Okay, P is of mass 2.5 kg. So let's suppose, let me just divide the paper into two halves. Now this is there is this particle P. Okay, and its mass is, this is mass of this P is 2.4 kg. The particle is then attached to a light and excentric string of length 4 meters. Okay, so this is going to be, oh, the string passes through a smooth hole in the center of the disk, and at the other end, oh, this is basically going like this. This is, yeah, so this one is vertical. Here is the particle Q, here is the particle P. Okay, and its mass is, the mass of the particle Q is 3 kg. Guys, I can show this this weight down here. This is 30 newtons. Okay, and the weight of this particle P is 24 newtons. Okay, now he says this the coefficient of friction between P and the disk is 0.2. So we have been given mu as 0.2. Okay, Q is hanging freely. Okay, you see, this is the sparrow. This just accidentally entered our room. I had to catch it, and now I'm going to free it. Look at this sparrow. This just, I think this wanted to study further maths. Can you see this? Okay, I'm going to free it now. Oh, okay, now back to the work. Okay, so we were on to this 10th question. Now we were here. Yeah, the coefficient of friction between P and the disk is 0.2. So I have to show the weight. So here, this R, like if this is the table over here, this is like, moving in this circular path. So this is the R over here. Okay, so when this is the R, we can determine the frictional force using the formula F equal to mu R. So that would be for this point P, there is this one force upward, the other is downward. So this R is absolutely 24. So this is 0.2 times 24. So this is going to be 4.8 newtons. Okay. Now he says, where are we? Yeah. Now the Q is hanging freely under the hole in the disk. So when this is hanging freely, it is not moving vertically. So that means there is this tension T holding this upwards. Okay, this is in a state of equilibrium. So we can say that, and here this the same string. So I have to show the tension T here as well. So this T is basically 30 newtons with us. Okay. Now, if you rotate this particle with a very high speed, what will happen that this particle P might leave this circular path. Okay, and this, like, this string is this string might break. Okay, and this has to go, like, in this would be accelerated in this side. Okay, now you have to see how many forces are acting on it. One is this tension in the string. The second is the frictional force. Okay, that will obviously be moving opposite to the direction of its motion. Okay, and then the third force is going to be the force that is F is equal to mr omega square. Okay, now when this is, you see there are three forces, T, and then the F, this F, sorry, the force acting towards the center. This is the accelerator. I should name it as X so that we don't get confused again. Okay, now there can be two cases of this equilibrium, like, this is this limiting equilibrium thing. One when this P is about to slide inside. Now in this case, this tension would be trying to pull this P towards the center of this circle. Okay, when this would happen, that force due to its acceleration, that will try to work with the resisting force so that this remain in this circular path. So for that case, this F and this X would be equal to this T. F plus X, that is equal to T. And in the case when this particle P is about to move outside this circular path, this is the case when this is going to move inside towards because of this tension. Now if it moves very fast, then this F would become obviously this would be increased. So now this frictional force work with the tension force to keep this moving in this circular path. So in that case, this T plus X, that would be equal to this F, that would equate this F. Okay, so this would give us two extreme values of this F. Obviously this F is a variable over here depending on its circular circular speed. Okay, so now this F is, he's asking, he says if Q does not move at any point during the motion, find the range of speeds possible. So we shall be using the formula, this F, instead of this we shall be using mv square over r. Okay, so guys, this is going to be m, the mass of this P, which is 2.4, and then V has to be found. Okay, V square, the radius is, I didn't note it down, the radius was, what was the length of the string over here? Let me see, particle P, this, the particle is attached to this, oh yeah, this is length 4 meters, this is 4 meters, okay, and yeah, this was 1.2. Basically the whole string's length is 4 meters, so this part is 1.2. So this is over 1.2 plus this X, which is 4.8, and that is going to be equal to the T, which is going to be 30. Okay, so this will give you one value, if I just simplify, this is 2V square, that is 25.2, and this V square is, let me divide 25.2 divided by 2, and then I take its square root. So this is going to be, V is going to be 3 under root 35 over 5. Okay, now this, for this case, this T is, we know that this is 30, and this one is X is 4.8, and your F is, I'm taking this F from here, which is 2V square. Okay, so this 2V square is 34.8. You see, this 2V square was 25.2, so this is going to be the smaller value, and this is going to give us a bigger value. So this V is going to be, this is 34.8 divided by 2, and then we take the square root, and this is going to be the square root of 435 over 5. So this means this would be in equilibrium if V remains within this 3 under root 35 over 5 and 435 over 5 square. Okay, so my students, you can try all the questions of this exercise, and I do recommend that please do these questions over here, like all these work examples, and so that your concept is clear. Inshallah, you will be able to attempt the past paper questions as well. Okay, so inshallah I'll be coming soon with the next part where we shall go to the next exercise question. Okay, thank you very much. Allah Hafiz.